Okay, so are you ready to dive into some seriously groundbreaking science today?
Absolutely. I think we're on the verge of something truly historic.
Yeah, the past 24 hours have seen some announcements that are really paradigm shifting, you know?
It's not hyperbole to say these discoveries could fundamentally change how we understand and interact with the world around us.
We're going to be diving into three major breakthroughs today, so buckle up.
It's going to be a wild ride, for sure.
So first up, let's talk about Evo 2, this AI that's been making headlines.
It's more than just reading the language of DNA. It's writing it, designing new genomes.
It's predicting disease-causing mutations with incredible accuracy too, right?
Yeah, over 90% accuracy in tests they did on the BRCA1 gene, which is linked to breast cancer.
Wow, so think about the possibilities for early diagnosis and personalized medicine.
Exactly. Imagine identifying potential health risks before they even become a problem.
It's incredible.
And it's not just prediction. Evo 2 can actually design new genomes from scratch.
So like synthetic biology taken to a whole new level?
They've already created a functional yeast chromosome with it.
Wow, that's a massive step forward.
Could revolutionize everything from agriculture to biomanufacturing.
And it's open source, right?
That's right. Any researcher can use it.
So that's kind of like giving the keys to the genetic engine to the entire scientific community.
It is, and that's both incredibly exciting and a little bit terrifying, to be honest.
Yeah, for sure we're talking about manipulating the building blocks of life itself.
The ethical implications are huge. We need to be having some serious conversations about responsible use.
Absolutely. We'll definitely be diving into those ethical considerations a bit later, but for now, let's move on.
Sounds good.
Okay, so we've talked about manipulating life. Now let's talk about accelerating the pace of discovery itself with Google's AI co-scientist.
This is where it starts to feel like science fiction is becoming reality.
Right.
This AI is like a tireless research assistant working around the clock.
Sifting through scientific literature, generating hypotheses, designing experiments.
It's like having a whole team of brilliant scientists working alongside you, but at warp speed.
Okay, so get this. It independently rediscovered a breakthrough in antimicrobial resistance that took human scientists 10 years to find.
And it did it in 48 hours.
Yeah, 48 hours. I mean, what does that tell us about the future of scientific discovery?
It's mind-blowing. We can potentially solve some of humanity's biggest challenges like climate change or finding cures for diseases like cancer much faster.
And it's not just about finding answers, it's about asking better questions, right?
Exactly. The AI co-scientist is pushing the boundaries of scientific inquiry itself.
Okay, so we've got an AI that can manipulate DNA and another that's accelerating scientific discovery. But what about the computing power to make sense of all this new information?
That's where Microsoft's Majorana 1 comes in.
Right, quantum computing.
The Majorana 1 is the world's first quantum chip that uses a completely new approach, harnessing the power of Majorana particles.
Okay, I gotta admit, the whole concept of Majorana particles and topological qubits is a little over my head.
Yeah, it's pretty complex stuff, but I'll try to break it down.
Please do.
Imagine you're trying to balance a pencil on its tip, incredibly unstable, right? Traditional qubits are kind of like that, very sensitive to noise and can easily lose their quantum state.
Okay.
But Majorana particles are different. They're like a pencil that's balancing itself because of its shape. They're inherently stable.
So they're ideal for building powerful quantum computers.
Exactly. And that's the breakthrough here. Microsoft has designed this chip to scale up to 1 million qubits.
1 million qubits, that's insane.
It's a level of computational power unlike anything we've ever seen before.
So let's try to connect all this back to that idea of a second scientific revolution. We've got Evo 2 manipulating the building blocks of life, the AI co-scientist accelerating discovery, and Majorana 1 providing the computational muscle to process it all.
Are we on the cusp of something that big? I think it's more than just possible. It's probable.
Wow.
These three breakthroughs together represent a fundamental shift in our ability to understand and manipulate the world around us.
Well, hello, it's Dave here. I am glad to be interrupting your listening experience with this nonsense. I've just been checking out Notebook LM to see where we have been on this crazy AI Today adventure over the past few months. From talking about Dario's mission from the Mount, he's the CEO of Anthropic, all the way through to supply chain success, how we do incredible things with Microsoft 365 Copilot. I've never said Microsoft before. I must be going soft. How you manage unstructured data, whether AI can help us better understand ourselves with a special cameo by Psych 101, an incredible data set of behavioral attributes over the period of many, many years, developed and nurtured by researchers. Stuff about I don't know, making AI work at work, AI-powered product management, knowledge graphs, finding solutions. My experience in developing an app for the first time in 42 years. Wow. Truth About Coding with AI was the episode yesterday. We've got so much stuff coming up, and we've already been reviewing Grok 3, ChatGPT with psychotherapy. My God, so many things. And I really hope that you're enjoying this journey with us. So, my question to you, do you want to get involved in more meaningful ways? I love having you here as a listener, but if you want to get involved as a sponsor, or if you want to come on the show and talk about your new AI-powered product, I would love to have you here with us. So, and you might even get to talk to a human. You can email me at dave@wordandmouth.com, or you can catch me on X at Dave Thackeray. I'm also on the usual platforms, Mastodon, big shout out, Blue Sky, and obviously, last but not least, LinkedIn. So if you want to get more from AI today, I want to hear from you. Back to the show.
It's like the scientific method itself has been turbocharged.
Exactly, and that's both exhilarating and daunting. We're entering uncharted territory.
The potential is huge, but so are the risks.
We need to proceed with caution, but also with a sense of wonder and excitement about what the future holds.
Absolutely. Okay, so let's dive a little deeper into each of these breakthroughs, starting with Evo 2, this AI model developed by the Arc Institute in collaboration with NVIDIA, Stanford, UC Berkeley, and UCSF.
They trained it on a truly vast amount of biological data.
We're talking about 9.3 trillion nucleotides from over 128,000 genomes across all domains of life.
Ego 2 has essentially been exposed to an incredible diversity of genetic information, allowing it to learn patterns and relationships that would be impossible for humans to discern.
And it's not just about the size of the data set either. It uses a unique architecture called striped 2, which is specifically designed to handle the complexities of biological data.
Right. Previous models couldn't process such long sequences of DNA, but striped 2 allows Evo 2 to read much longer chunks.
So it's getting a much deeper understanding of the intricate interactions within genomes.
Exactly, like moving from decoding individual words to understanding the language of life itself.
And that's leading to some really incredible results, like being able to predict disease-causing mutations with remarkable accuracy.
You mentioned the BRCA1 gene, but they've tested it on a variety of other genes, and the results are consistently impressive.
This kind of accuracy could be transformative for personalized medicine.
Imagine getting your genome sequenced and having an AI analyze it to identify potential health risks.
Allowing for preventative measures and early interventions.
Right, and then there's the potential to design entirely new genetic sequences.
Researchers are already exploring Evo 2's potential for gene therapies engineering crops with enhanced traits, even creating new organisms.
It's like having a genetic toolkit at your fingertips.
The possibilities are mind-boggling, but with this power comes a great deal of responsibility.
We need to tread carefully and have open conversations about the ethical implications of manipulating the building blocks of life.
Absolutely. We'll definitely be diving deeper into those unethical considerations later on. But for now, let's shift gears and explore the next game changer, Google's AI co-scientist. So this AI co-scientist, it really is like having a superpowered research partner. You know?
One that never sleeps or gets tired.
Yeah, constantly crunching data and analyzing information.
It's built on Google's Gemini 2.0 and operates like a multi-agent system.
Multi-agent system, so like a team of AI agents all working together.
Exactly, each with its own expertise tackling complex scientific problems.
So instead of one scientist working alone, they've got this whole AI team backing them up.
Generating hypotheses, designing experiments, analyzing massive data sets.
It's incredible. And it's already producing some amazing results.
Like in drug discovery?
Right? It's identified potential treatments for acute myeloid leukemia.
And discovered new targets for treating liver fibrosis.
And then there's that crazy story about it rediscovering that antimicrobial resistance breakthrough.
The one that took human scientists 10 years to find.
And the AI did it in 48 hours.
It just shows you the potential for accelerating scientific discovery.
It really does. It's like the AI can see connections and patterns that we might miss.
It's not just finding answers, it's helping us ask better questions.
Pushing the boundaries of what we thought was possible.
Exactly.
But hold on. If the AI is doing all this work, generating hypotheses, designing experiments, what's the role of the human scientist?
That's the big question, right? Are we becoming obsolete?
Kind of feels like it sometimes.
I don't think so. At least not yet. I see the AI co-scientist as a powerful tool.
An extension of human intelligence.
Right, not a replacement for it.
So it's about collaboration.
Exactly, a partnership. The AI provides the raw processing power, But the human scientist brings the intuition, the creativity.
The ability to interpret the findings and ask the really insightful questions.
The AI might point us in the right direction, but we still need to decide where to go and how to get there.
So it's like having a super intelligent research assistant.
One that can handle all the tedious work, freeing us up to focus on the big picture.
I like that analogy. Okay, so EVO 2 is giving us the ability to rewrite the language of life. The AI co-scientist is accelerating the pace of discovery, and now we need to talk about the computing power to make all of this possible.
No, me again. Right. How are you using AI in your business? Have you got beyond getting ChatGPT to write your emails for you? Are you integrating Tensor Lite into your manufacturing processes? Have you figured out how to use Free Agent? That's right. That's the accounting and invoicing software, Free Agent AI, to take control of your money. What have you been doing with AI? I can't wait to find out. Drop me a line, dave@wordandmouth.com. I would really like to shout about the progress that you're made. This show is all about productivity, efficiency, and getting the edge over your competition while at the same time keeping your humans happy. So I want to hear all of the different ways that you've started on this path to AI integration in your organization. Can't wait to hear from you. Back to these guys.
Which brings us to Majorana 1 and the world of quantum computing.
Right, this is where things start to get really mind-bending.
Quantum computing harnesses the principles of quantum mechanics to perform calculations that are impossible for traditional computers.
And the Majorana 1 uses a completely new approach.
Harnessing the power of Majorana particles and topological qubits.
Okay, I gotta be honest. The whole concept of topological qubits is still a bit fuzzy for me.
It's definitely complex stuff, but I'll try to explain it in a way that makes sense.
I appreciate that.
Okay, so imagine a coin spinning in the air. It can land on heads or tails, right?
Right.
Now imagine that coin spinning so fast, it's in a blur both heads and tails at the same time.
Okay, I kind of see where you're going with this.
That's kind of what's happening with a qubit. It can be in multiple states simultaneously.
And that's what makes it more powerful than a traditional computer bit.
Exactly. A traditional bit is like a light switch. It's either on or off, representing a 1 or a 0.
Okay.
But a qubit is like a dimmer switch. It can be on-off or somewhere in between.
So it can represent a much wider range of possibilities.
And that allows quantum computers to perform multiple calculations at the same time.
Giving them a huge speed advantage.
For certain types of problems, yes.
But what makes topological qubits so special?
Well, traditional qubits are incredibly fragile.
Any disturbance can cause them to lose their quantum state.
Exactly. Like trying to balance that spinning coin on its edge, any little vibration will topple it over.
So topological qubits are more stable.
Much more stable. They're protected from decoherence by their physical structure.
It's like the spinning coin is embedded in a groove, making it harder to knock off balance.
Precisely. And that's why they're so promising for building large-scale, reliable quantum computers.
And that's what Microsoft is aiming for with Majorana 1.
Yes, they've designed this chip with scalability in mind.
They believe they can scale it up to 1 million qubits on a single chip.
Which would be a truly unprecedented level of computational power.
So 1 million qubits, what does that actually mean in terms of real-world applications?
Well, we're talking about revolutionizing fields like materials, science, drug discovery, artificial intelligence, cryptography.
It's hard to even fathom the possibilities.
Imagine designing new materials with properties we've never seen before.
Or discovering life-saving drugs in a fraction of the time it takes now.
Or creating AI that surpasses human capabilities.
Breaking the most complex encryption codes.
The possibilities are pretty much limitless.
It's both exciting and a little bit terrifying, to be honest.
I agree. The power of this technology is immense.
And that's why it's so important to have these conversations about the ethical implications.
We need to make sure this power is used for good, not for harm.
Absolutely. It's not just about the technology itself, but about the societal implications.
We need to think about safeguards, about regulation, about preventing misuse.
We need to be proactive, not reactive.
Exactly. Anticipate the potential risks and develop frameworks to mitigate them.
This isn't just a job for scientists and engineers.
It's a conversation that needs to involve policymakers, ethicists, philosophers, everyone.
Okay, so we've explored these 3 groundbreaking advancements, EVO 2, the AI co-scientist, and Majorana 1.
It's clear we're on the verge of something truly revolutionary.
A potential second scientific revolution.
One that could reshape our world in profound ways.
But before we get too carried away, let's take a step back and consider the bigger picture. Okay, so we've explored all these incredible advancements, EVO 2, the AI co-scientist, Majorana 1. It's a lot to take in.
It really is. It feels like we're on the cusp of a whole new era of scientific progress.
Some are even calling it a second scientific revolution.
And I think that's an apt description. These are not just incremental improvements. We're talking about fundamental shifts of our understanding and capabilities.
You mentioned earlier the concept of an exponential age, where scientific progress is happening so fast, it outpaces our ability to comprehend it.
Yeah, it's a bit mind-boggling to think about, but I think that's where we're headed.
So what does that actually look like? What does it mean for humanity to live in an exponential age?
Well, imagine a world where diseases are eradicated before they even emerge,
Wow.
where we can design materials with properties that defy our current understanding of physics.
Like self-healing materials, or materials that can convert sunlight into energy with near-perfect efficiency.
Exactly, and where the mysteries of the universe are unlocked at an astonishing rate.
It sounds incredible, but also a little bit daunting. Can we handle that kind of rapid change?
That's the big question, isn't it? We need to be having serious conversations about the ethical and societal implications of these technologies.
Right? Because with this kind of power comes a great deal of responsibility.
Evo 2 alone raises so many questions about the ethics of manipulating life.
Where do we draw the line? Who gets to decide how these tools are used?
And then there's the AI co-scientist. What does it mean for the role of the human scientist if an AI is generating hypotheses and designing experiments?
And let's not forget about the potential for misuse. Quantum computing could be incredibly powerful in the wrong hands.
We need to be thinking about safeguards, about regulation, about how to prevent these technologies from being used for malicious purposes.
So it's not just about the science, it's about the ethics, the philosophy, the societal implications.
We need to approach this new era with a sense of both wonder and caution.
It's a lot to consider. So I have to ask, are you optimistic about the future?
I am. I really am. I believe these technologies have the potential to solve some of humanity's greatest challenges.
But only if we use them wisely.
Exactly. It's going to require a collective effort, a willingness to have those tough conversations, and a commitment to using these tools for the betterment of humanity.
It's a tall order, but I think we're up to the challenge.
I agree. We're standing at the precipice of a new era, and it's up to us to decide what kind of future we want to create.
Well said. Well, on that note, I think it's time to wrap up this deep dive into the potential second scientific revolution.
It's been an incredible journey.
We've explored some truly mind-blowing advancements and grappled with some big questions about the future.
And to you listening, we encourage you to continue exploring these topics, to stay informed, and to engage in the conversation about the future we're building together.
Because ultimately, the future is not something that just happens to us.
It's something we create.
That's all for this episode of The Deep Dive. Thanks for joining us, and until next time, keep exploring the depths of knowledge.